So let's take a look at finding the determinant of a 2 by 2 matrix and using that for Cramer's rule. So just as a little bit of background, a determinant can be found from any square matrix. Now when I say square, 1 by 1, let's say that's just a 3 or whatever. I have a 2 by 2, right? We got things there and there. I have a 3 by 3. So it has to be a square matrix, right? Rows and columns have to be equal. And if that's the case, there is a determinant. Now, the way we find a determinant, first of all, in a 1 by 1, you're wondering how in the world would I find a determinant that way? All I have is one thing. That's the actual determinant, is the actual single digit. So let's take a look at how we find determinants on, let's say, 2 by 2s. What we do is we multiply diagonally across. So I say 2 times negative 1. And I subtract the other direction's product. So minus 3 times 4. Okay, so that's negative 2 minus 12. Looks like that's going to be a negative 14. There's the determinant for that 2 by 2 matrix. 2 times negative 1 minus 3 times 4. Really simple. Let's take a look at the next one here. So we have this. Negative 3 times 24 is negative 72 minus 9 times 8 negative is negative 72. So I didn't give you individual steps, but you can look at the multiplication. And now that becomes a plus, and this becomes 0. Now, when you have a determinant that's 0, okay, this is when we can't use Cramer's rule. You're going to see why in a minute, because I'm about to do Cramer's rule. Okay, so we can't use Cramer's rule when the determinant is 0. All right, so let's take a look at using Cramer's rule. What in the world do you say is Cramer's rule? Well, Cramer's rule is a method of solving any number of variables as long as we have the same number of equations as variables, okay? And if it's actually solvable, meaning if there is a solution. So let's take a look at this. There are 3 steps basically that we work through to prepare for Cramer's rule, and that one of them is we find the determinant of the coefficient matrix. Okay, so I'm going to call that capital D. Now the coefficient matrix, we know for this one would be, oops, I'm going to say that's D. So the coefficient matrix for this would be 1, negative 1, and 2, 1. There's the matrix for the coefficients. Okay, now the matrix for the constant is this, right? Okay, so I'm just writing those down so that I can use them for my determinant here. All right, for regular D, okay, I'm just going to take the determinant of the coefficient matrix. Now, here's how I show the symbolic, the way that I show in symbols how we're getting the determinant. It looks like I'm using absolute value, but it's not absolute value. So you notice before it's just a matrix, right, with the brackets, and now it looks like absolute value. That's the symbol for, hey, take the determinant. Okay, so here we go. We're going to call that determinant D. So I have 1 times 1 minus negative 1 times 2. Okay, this times this minus this times this. And that's going to give me, I'll just put it over here. That's a plus, so that's 1 plus 2. That gives me the determinant 3. Now, I'm going to get 2 more determinants. And the next one I'm going to get is determinant sub x, meaning the determinant for the x. So now watch this. I'm going to go ahead and tell everybody who's looking on that this is the determinant that I'm supposed to find. But watch. I'm going to copy the coefficient matrix, but in the x column right here, this first column, I'm going to substitute in the constant column matrix. Now watch. The y stuff stayed the same. The second column stayed the same. The first column did not stay the same. We substituted in the constant, okay, matrix. So now let's find the determinant for that. So we have that times that minus negative 1 times 7. So that's 2 plus 7, that's 9. Let me put it over here. That's equal to 9. Try to be consistent. All right, how about d sub y? Well, that's the determinant that's going to be used to find y. And this time, you guessed it, we're going to put in the constant for the y. Constant column matrix and substitute it in for the y. So here we go. Let it go back to the original, but then put a 2, 7. Okay? So let's see. We've got 1 times 7 minus 2 times 2. Well, 1 times 7 is 7 minus 4 is 3. Okay? There's that times that. Now, let me show you how we're going to get this, what we put together to find that. This is basically how to solve the system, right? We know that solving a system is finding the variables of the system. So, to find x, we're going to put capital D over D sub x over to capital D. So let's see what that is. D sub x, what's the determinant for that? There it is, 9. What is D? 3. So we get that x is 3. There's my x coordinate. Now let's get the y. We're going to have d sub y over d. So here we go. D sub y is 3 over d, which is 3. And so the y value ends up being a 1. So my answer is 3, 1. It's just the point that is the solution, the xy coordinate that is the solution for that system. And there it is right there. The key is finding these determinants. Okay, notice that none of them were 0. Let's take a look at one more. All right. So I'm going to move this over, right? Just look at your equations and make sure that they're actually in standard form, or at least close to standard. I'm going to leave that 6 negative, so it's really not standard form. So let me write my coefficient matrix. 3, 1, negative 6, 1. There's that. My constant is going to be negative 5, 50. Okay, so here we go. Let's go ahead and get our determinant for the coefficient. So that's 3, 1, 1, and negative 6. Remember, this one, nothing changes. So that's 3 minus negative 6. That's going to give me 9. Now we're going to get the one where we substitute in for the x column. So I'm going to put negative 5, 50. And I'm going to go ahead and write the rest of the matrix as I see it. So negative 5 minus 50 is negative 55. Okay. dy is, let's see here, that's going to be, I keep the x column and I substitute this for the y. Alright, so let's see what this one is and finish this up quickly. So we have 150, that's this times this, minus negative 5 times negative 6. So that's going to be a positive 30. So 150 minus 30 is 120. Alright, so now let's go ahead and put together our information. To get the x, we're going to put negative 55 over 9. Okay, and that's it. Right? For the y, we're going to put what? We're going to put 120 over 9, and that's going to reduce, divide by 3, that's going to be 3, and that's going to be 40. So that's going to be 40, oops, I didn't mean to do that. That's going to be 40, oh my goodness, 40 thirds. Okay, so my answer ends up being negative 55, kind of weird answer, but they don't always have to be nice, neat little integers. So there you go. There's your answer, your xy coordinate. That is the solution to that system right there. All right, I hope this was helpful. Thanks for watching.